Know if you have questions to go with this as well. So the first thing I'd encourage you guys to think about is identifying that this right here, of course, is a fraction. It's a quotient. And that whole quotient, that whole fraction, has this exponent of 4 on it. And so that means that exponent of 4, it applies to every single part of the fraction. So some people call this the distributive property. It's not really the distributive property. What I'm going to do is I'm going to say that this exponent of 4 applies to this base of 2, the base of y. It also applies to the base 3 as well as the base x. And how you deal with those exponents is going to be key. Please keep in mind that the 2 right here, please stop with the snapping there. Thank you. The 2 right there is a base, and the 4 is an exponent. So as a first step, I would probably write this, 2 to the 4th. 2 to the 4th. And then a key piece here is, what do I do with those exponents there? Do I add, subtract, or multiply? What do I do? The 3 and the 4 I just circled there. You multiply. Whenever you have a base to a power, to simplify, you multiply your exponent. So this would be 2 to the 4th, y to the 3 times 4, of course, is 12. So 2 to the 4th times y to the 12th. Then down in the denominator, that 3, which is a base, that exponent of 4 still applies to it. So it would be 3 to the 4th. And then what do I do with these exponents here, the 4 and the 2? Add, subtract, multiply? You multiply, yep, that's right. So when I multiply those together, I get x to the 8th. This is a pretty good step right here. We haven't simplified completely because there's a little more work to be done. So I'll do that and I'll be done. 2 to the 4th is 16, y to the 12, and then 3 to the 4th is 81, and we still have x. Let's try that again. X to the 8th, there we go. So this is it. We're done at this point. The y to the 12th over x to the 8th. A couple folks said, hey, can't we subtract those exponents? Can anybody explain why we cannot?
Because they're different bases.
They're different bases. Yep, you've got a y for a base and x for a base. Just like Paige said, because they're different bases, you cannot simplify like that. So, hey guys, will you do a quick self-assessment? Listen, please. Quick self-assessment. If you got all the way to this on your own, obviously you're in really great shape. You understood this concept really well. If you needed some help, maybe you missed it, maybe you struggled, can you identify where you struggled? I forgot that this was a base. I forgot that 2 to the 4th was 16. I don't know, I forgot to multiply the exponents. Whatever the case might be, if you can self-assess and try to do a little bit better on this next one. But before we move on, do you have any questions? All right, fair enough. Let's take a look at this one then. It's right here. Similar looking question. Right there. See if you can simplify it completely, that one. What I would want to do here is, in the spirit of order of operations, I'd want to handle kind of the grouping symbols in that exponent there. In other words, I want to simplify this before I do anything else. You don't have to do it that way, but I think that would be kind of a nice way to do it. I would say that this squared applies to every factor on the inside. And so maybe a first step would look like this. X times 3 squared times x to the, what do I do with the 5 and the 2? Do I add, subtract, or multiply those two exponents? Multiply, right? Because isn't it a base to an exponent to another exponent? That would give me x to the 10th. And then lastly with the y, I've got y to the 4th squared. That would give me y to the 8. Thank you. Okay, denominator is just 5xy. It's a good start. Let me keep going here. I've got 2 pieces that could be simplified up here on the top. What's the exponent on that first x right now? There is not one written there, so what do we understand it to be? It's a 1, yep. So then if I do x to the 1st times x to the 10th, what do I do with my exponents? Add them up, yeah. You guys know that 3 squared is 9, and 1 plus 10 is 11, so I get 9x to the 11th, y to the 8th, over 5xy. Last thing I need to do is recognize that I've got an x in the numerator and an x in the denominator. Same thing with the y's. Let's keep in mind that the exponent on that x is a 1, and on the y also a 1. So if I am dividing like bases, what do I do with the exponents? Add, subtract, or multiply? Subtract. That's exactly right. Subtract. So this ends up being, for a final simplification, 9x to the 10th, because 11 minus 1 is 10, y to the 7, again because 8 minus 1 is 7, and the 5 does not get to go anywhere. That would be my final simplification, 9x to the 10th, y to the 7th over 5. Can I ask you guys a couple questions? Why is it that I don't go maybe another step here and say 9 minus 5 is 4?
Because
And-
you can't.
Why not?
Because they don't have the same thingies, X and Y.
Okay, well the 9 and the 5 are both what?
Bases.
They're both bases, and if they are both bases, that means they're not exponents, right? And if they're not exponents, I can't treat them like exponents. 9/5 is just 9/5. There is no subtracting of exponents there, and they are even different bases. Let's see here. Yeah, I guess I'll leave it at that unless you have questions. This was a more challenging one, wasn't it? I could see. Yeah, you guys are definitely working hard. Let's, you want to do one more kind of like this?
Yes, please.
Okay. Let's see where we go with this. First thing I would do here is I would try to handle that whole expression with parentheses and the squared. And so I'm going to try to recognize here that the squared applies to every single base in the parentheses. So my first step would look something like this. X times, I'm going to get rid of the parentheses here because once I've done the exponent, parentheses really don't need to be there anymore. So it's going to be x times 5 squared, x to the 4th, y to the 18. Where I got the 4 and the 18 is I multiplied the exponents. 2 times 2 is 4. 9 times 2 is 18. I'll be leaving the denominator alone for now. And I get here. So stop and look. Are there any questions? Why is this there? Why isn't that there? Whatever. Okay. Question? No? Okay. So continuing on, we know that 5 squared is 25. And then, kind of like before, what's the exponent on that x right there? It's a 1. So doesn't that mean that the exponent on the other x is also a 1? They're both 1s. Okay, so then I've got x to the 1 times x to the 4th. If I am multiplying like bases, I leave the base the same, and I add. Yeah, that's right. Add the exponents up. Of course, 1 plus 4 is 5. So x to the 5. Y to the 18, leave that alone. Still have that denominator. And this could be one of those times where you look at this and you think to yourself, man, I've done a decent amount of stuff. I must be done. And it's true, you've done a decent amount of stuff. But listen, you're not done. How do I know, how do you know that you're not done?
Simplification. It's not simplified.
How do we know it's not simplified?
Because it's not.
Besides that circular reasoning, how do we know, Ashley? Because I've got x's in the top and bottom, right? Yeah. I've got an x here and an x there. I've got a y here and a y there. And like she said, you can subtract. That's what we'll do. So lastly, I would say if I am dividing like bases, I subtract exponents. 18 minus 5 is 13. The denominator is still 3. Leave that as is. And you're done. Okay, so definitely feel like you all did better on that one than on... If you would, I hope that you... It's going to work? It does work. Sum it up in just a really brief statement. What does a negative exponent tell us to do? Be really careful with that. Like we always say put it in the denominator, but what if it's already in the denominator? Then you put it to the numerator. So instead of saying put it in the denominator, I'm usually going to say flip it to the other level. If it's in the numerator, put it in the denominator. If it's in the denominator, put it in the numerator. So with a question like number 7, how many bases are there in number 7? 2. There are 2 different bases. The first one is 16. What is the exponent on the 16? 1. Agreed. And the other base is that t. The exponent on the t is negative. So when it comes time to simplify this, here's what it's going to look like. 16 over t to the fourth. The reason why the 16 stays in the numerator is because the exponent on the 16 was positives. The reason why the t flips down to the denominator is because the exponent on the t was negative. Pretty simple process there. Not easy necessarily, but that's simply what it is. If the exponent is negative, the base goes to the other level. If the exponent is positive, then the base would stay wherever it is. Take a look then at number 8.
What? Sorry.
Sorry?
No, I'm sorry. I got. No,
Grace, did you have a question?
I'm sorry. I didn't mean to say it so loud. I just
Okay, it's fine. In number 8, you could think of this in a couple different ways. You could think of there being 2 different bases on number 8 or just one. The bottom line is you do have that negative exponent. Technically on the 7, you could do this in a couple different ways. If you're going to simplify this completely, here's one way. You could write this as 1 over negative 7, and then the squared is on that 7. Of course, we know that 7 squared is 49. This would end up being 1 over negative 49. You could also have negative 1 over positive 49. Those two answers are the same. Makes no difference which one you have. Excuse me, but that would work. What?
Sorry.
I'm just messing with you. Go ahead, Grace. Hey, I figured if she could do it to me, I can do it to her. How about that? Go ahead, Grace.
I don't know if you've already answered this, so I'm sorry if you have. But on number 7,
Yes.
could you do the same? Could you just do 1 over 16t4?
No, and the reason is the 16.
Stop. Sorry.
It's okay. The 16 is its own base, right?
Yeah.
The 16 is a base, and what's the exponent on the 16?
4.
No,
More.
1. Specific, and that's it's 16 to the first. Grace, can I show you a contrast?
Yeah, but I just don't understand how it's 16 to the first when there's no variable. There's no automatically. There's always if there's nothing.
So,
There's 2 bases.
hey guys, hey gentlemen over here. Hey, hush. So Grace, listen. So anytime you've written a number, and you didn't know this, of course, when you were a little kid, but if you wrote, like when you're first learning about numbers, you wrote the number 9, isn't it technically 9 to the first? Like when somebody's teaching you to count, they'd never say that's 9 to the first, they just call it 9. But if there's no exponent written, it's understood to be a 9, or understood to be a 1, so like 9 to the first, right? Same thing with a variable. Like if you have a variable, say like x, and there's no exponent on that variable, and somebody says, well, what's the exponent? You'd say, well, technically it's a 1.
But there is no variable. After the 16, there's only the t, which is the variable.
But if you have a numerical base like a 9 or a 16, and there's no exponent on that, we understand it to be a 1.
Okay.
So if you have 9 to the first, if you have 9x to the 8th or something like that, that absolutely does not mean that that exponent of 8 applies to the 9. It means that the 9 has an exponent of 1, 9 to the first x to the 8th. What I think you're doing is you're thinking of it as 9x in parentheses to the 8. If you have that situation, doesn't the 8 exponent apply to both the 9 and the x?
Yeah.
But in this situation, the 8 exponent only applies to the x, not the 9.
So, okay. Okay.
Does that make sense?
Yeah.
Okay. That's a tricky one. A lot of folks struggle with that.
Okay, great.
Ashlyn, your question.
On number 8, why would negative 49 because wouldn't it be positive?
Yeah. Hey, guys. Listen up, please. So Ashlyn asked, why wouldn't it be positive 149? It has to do with, are there parentheses there or not? So let me contrast this. If we had a slightly different question, this is a different question. If I had this, then this would proceed the way that I think you're thinking of it. So if we had that right there, what we would do is we'd say that this negative exponent means to flip down. So it would be 1 over parentheses negative 7 squared. And negative 7 in the parentheses squared really means negative 7 times negative 7, which is positive. So that would be positive 149th. This one over here that we just did is different. Notice how the negative is not in the parentheses? And so because the negative is not in parentheses, all this is really saying is we want to do the opposite of 7 squared.
Okay.
So as I go through that flipping, I mean, the exponent is still negative, so we still flip it down. So it'd be 1 over, it'd be the opposite of 7 squared. And the opposite of 7 squared, well, we're going to do the exponent first, right? Order of operations. So that would be 49. But the negative that was here hasn't gone anywhere. Negative 149. Make sense?
Yeah.
So the key there is, are there parentheses around the thing that's being squared? Yes or no? That'll make the difference. Okay, number 9 says 3 over d to the negative 9th. As we said before, if the base has a negative exponent, you need to flip it to the other level. You can clearly see the d has a negative exponent. But what's the exponent right now on the 3? It's a 1, right? There is not an exponent. If there isn't, we understand it to be a 1. So that's 3 to the first. So that means the 3 is not going to get flipped anywhere. It's going to stay in the numerator because it's got a positive exponent. But that d, because it has a negative exponent, is going to get flipped to the other level. So this would be 3 to the first times d to the 9th. So you think of it as 3d to the 9th. That make sense?
Yes.
It's really important that we understand why something flips up or down and why something doesn't. We've got a couple of good examples there with 7 and 9. And then finally, number 10. We have 2 different bases on number 10, right? And don't both bases on number 10 have negative exponents? So since both bases have negative exponents, both bases flip. And so this would end up being 8 to the 2, 9 to the 2, right? The 8 would flip down, the 9 would flip up to the top. And then to finally finish this one out, we would simplify completely 81/64. 81/64. Okay. Basic examples with negative exponents. Any questions? Hope that went well for you. Okay, let's move on.
11.
Okay.
Just so you know, it's not. It's like,
These get a little tougher. A little more going on. So if you would, take a look at numbers 11 through 14. 11 through 14, and we'll try these together here in just a second. Where you're at, haven't got around to every single person, of course. But number 11, definitely kind of a sticking point. Some folks are like, man, I'm not sure quite where to start. Let me ask you this. Let me ask you hopefully some clarifying questions. In number 11, how many different bases are there?
3.
There's 3 different bases. The 3 bases are negative 15, r, and x. 3 different bases. Listen up, please. And of those 3 different bases, how many of them have negative exponents?
2.
Only 2 have negative exponents, and one of them has a positive exponent. Which base has the positive exponent?
Negative 15.
Negative 15. What's hard about this is it's a negative base, but it has a positive 1 for an exponent. So since negative 15 has a positive 1 exponent, it is going to stay where it is. But the other 2 bases, because they have negative exponents, they need to flip to the other level. So this is going to look like this. Negative 15 stays up there in the numerator, but the x to the negative 10 flips up to the top where it becomes x to the positive 10. R to the negative 6 needs to flip down to the denominator where it becomes r to the positive 6. And that, my friends, is all you can do with this one, right? Couple of flips of the appropriate bases and you're done. There's no other like bases, and so you can't simplify them any further than that. Any questions on number 11? Number 12. Number 12, this negative 2 exponent, it applies to everything inside the quotient. And so it is going to apply to the z. It's going to apply to the base of 15. So maybe a good first step would be this. Z to the negative 2 over 15 to the negative 2. Do you see how all I've really done here is apply that negative 2 exponent to both parts of the fraction? Now you look at it, don't both bases have a negative exponent? So they both need to flip. So this is going to become 15 to the 2, because that 15 had a negative exponent, over z squared, once again because the z had a negative exponent. And then if you simplify completely, 15 squared is 225. It'll be 225 over z squared. Okay, number 13. I'm kind of curious how you all did this. Did anybody look at number 13 and say, if you are multiplying bases, you add exponents? If you did it that way, I really like that way. I think that makes a lot of sense. That rule still applies. Let's go ahead and do it that way. What is negative 15 plus 4?
It's
Negative 11.
R to the negative 11, yep. And so since R has a negative exponent, it needs to flip. Right now it's in the numerator. And so I mentioned this in the video. If you ever have a blank numerator, what do you put in the blank numerator?
1.
1, yep. So be 1 over R to the 11th. Okay, and then the last one in this little group is number 14. And number 14 is right there. How many of you in number 14 think this is really the best way to do this in number 14? Did you guys look at this and say, if you are dividing bases, you subtract exponents?
No, I said no. Yes.
I think that's definitely a way to do it. I think it's probably the most logical way at this point. Keep in mind that when you do that, you always subtract top minus bottom. So n to the 7 minus 9, that would be n to the negative 2. And since n has a negative exponent, it gets flipped to the denominator. It becomes 1 over n squared. Okay, any questions? So here's what we're going to do. We got a few minutes left. We haven't really talked any about zero exponents, and I want to do that right now to see how you do with these zero exponents.
Well, I think they're kind of hard though, and like, can we maybe just wait till Wednesday to learn them so that because if we learn them at the end of class now and then
How about this one? That's 1, right? Because any base other than 0 to the 0 is 1. So that would be 1 right there. Let's think a little bit deeper about this. What if we had this? Pay close attention to the symbols that are and are not there. How about this? 5x to the 0. What's the answer to that one? It's 5 times, wasn't it 5 times x to the 0? So 5 times 1 is 5. How about this one? Remember, any base to the 0 is 1. So isn't 5x the whole base?
Yeah.
The whole base to the 0 is
1.
1. Again, just to compare, what's the difference between these two starts? Parentheses. Either there or not. This could be, I don't know, you might look at this and think that it's cruel, but check this one out. What do you think that one is? Isn't that 5? Right, x to the 0 is 1, for sure. 5 times 1 is 5. Question, Jake.
So for the, in parentheses, 5x times 0, or times the exponent 0.
This one right here?
Yeah, that one. If it was like, say, 5x to the, with an exponent of 1.
5x to the 1
Yeah,
to the 0?
yeah. You would times the two exponents. And then it would
Sure,
just
it'd be
5x.
5 to the 0, x to the 0.
Oh, okay.
And 5 to the 0 is 1, x to the 0 is 1. You get 1. Yep. All right, hey, thanks for your good work today. We will continue the practice.